Welcome back to the HCC. We are back once again. It is day 88. We are here to slay more more LC problems, particularly easy problems. Yesterday we got stuck on implementing a post-order traversal iteratively, so we're a bit stuck on that. But I think today we should still be stuck on it because I'm out of brain juice. I was doing a lot of other stuff earlier today, some CSS, some React, and then I fell down a YouTube rabbit hole. But yeah, I'm still out of brain juice, but I think we should be able to do a little bit of something here. But I'll generally be surprised if we solve it because my brain is fried. Good thing though, the sleep is back on track. But you're going to want to join the LC Easy Extinction Unit. We are recruiting members for the unit. We're about to go to war with LeetCode. So we're going to be decimating all the LC Easy problems. So you're going to want to join so that you can be part of the decimation or the LC Easy extraction unit. We're also going to be forming a very elite unit of LC problem solvers to solve all the hardest easies. So if you feel like you could be compatible with that squad, you're going to want to make sure to join the Discord. So make sure to join the hyperbolic coding chamber today. And yeah, we're just going to jump into it. I'm a little bit strapped for time today, so the intro is going to be short. We're just going to jump into it. We have 30 minutes. We have binary tree, post-order traversal, and some other problems set up. And oh yeah, one more thing. Yesterday's title was Goodbye HCC. That, I got to be honest, that was clickbait. And I fell into the clickbait hole. So yeah, hopefully we'll see. It's hard to resist the clickbait. Bait. So yeah, we'll try not to use more clickbait. But yeah, we're just gonna jump into it. We have 30 minutes on the clock, so let's just do it. So so we're doing a binary tree post-order traversal. We were trying to figure this out. We did a recursive version, and then we had trouble figuring out how to accomplish this iteratively because we have a time limit exceeded problem here. So I think what we should try and do, let's try and figure this out by using a simpler tree, right? And if we did post-order traversal on this with recursion, with a tree like this, the one that we're looking at right now, I guess maybe the output would look something like, since post-order is LRN, right? We could start at 1, go left. We are at 2, we go left, go right. There's nothing there, so we print 2. We back at 1, right? So we want to go R, right, and print 3. No, we go R, which is 3. We can't go left, we can't go right. So we would do N, which is 3, and then we'd be back at 1. So it'd be 2, 3, 1. Now if we check our current algorithm, right, we have a tree. Let's simplify our tree here. It would just be 1, 2, 3 like we have here, and we should still run infinitely. Our comments here are creating an issue. So just making sure we still get TLE. So we still get TLE, so this is good. And let's see why. So our current is going to start at root, right? We're going to start at 1, right? And then cur is not nil, right? So we're going to go in here. Cur is still not nil. So we're going to push 1 onto a stack, right? And then do cur equals cur.left. So now cur actually equals 2, right? And then we're going to say, okay, does cur equal nil? Well, 2 does not equal nil. So we're going to push 2 onto the stack, right? And then we're going to go left. So now cur is nil, right? So now we're going to end up out here. We're going to do cur equals stack.pop. We're going to be back at 2, right? So now cur equals 2, and the stack does not have a value in it. We're going to say cur equals cur.right. So now cur equals 2.right, which is now nil. Say, well, cur does not equal nil, right? But it does equal nil. So then we're going to do cur equals stack dot pop. Cur equals stack dot pop. So now cur would actually be equal to 1. Then we would push 1. So yeah, we actually keep going back down between 1 and 2. So we're just getting stuck basically. That is very strange. Ooh, just like if we start at 1. So this is clearly not going to work. So we keep going back up to 1. So if we go down left to 2, cur does not equal nil, stack dot push cur. Yeah, this is one that's very confusing to work at. We're at 2, but we're at 1. So we need to go down left to 2. Which we do when we come out. We're at 2 again. Now we'd like to go right. Let me just make sure that this would actually print 2, 3, 1. So do that, we're just going to return an empty array to see what the actual expected value should have been, and it should have been 2, 3, 1, so that is the expected outcome. We go down from 1, right? We can't go left anymore. Left, left. We go left, right? We can't go left anymore, so we're back at 2. Now we're going to go as right as possible from 2. So maybe we could I think the thing is, we were saying here before, we don't need to do pop. What if we just did stacks of -1? So we want to be back at 2, then we want to go right from 2 and go as far right as we can. Right, but it equals nil. Then we'll say cur equals stack dot pop. Then here's where we want to do So I think what we'd like to do is we don't want to set cur. We'll keep cur equals nil. Oh no, it will just pop twice. if we keep cur equals nil and then do instead stack.pop.val, right? So now I think with this version, if we check this out, we'll start at 1, right? 1 is not nil, so we're gonna push 1 onto the stack, right? And then cur equals cur.left, which is now going to be 2, right? Now cur is not nil, right? So we're gonna do stack.push cur, which is 2, and now cur is going to be equal to nil. Now cur, we're going to be outside of the loop. Now cur is going to be equal to 2, right? We're not popping anything, but then we're going to say cur equals cur.right, which is now nil. Well, cur does not equal nil. Well, cur is nil, so we're going to skip this, and then we're going to do r.push stack.pop.val, which would give our array 2, and then remove 2 from the end of it. Now cur is still nil here, so now we'd go back up here, right? Cur is nil, but the stack isn't empty, so we're at 1, right? Cur does not equal nil. Well, it does equal nil. We're gonna say cur equals stacks of -1, which is 1. Cur equals cur.right. So now we're gonna go right from 1, right? And 1 isn't nil, so we're gonna push on. We don't want to push on. Yeah, we can push on cur, because right, cur is now going to, let me update the things. Cur would now be equal to 1, right? We're going to say cur equals cur.right, which means now cur equals 3 for this array up here, and for this tree up here. We stack.push cur, which is good because we want to push 3, right? But we don't want to push a left. We're going to say cur equals cur.right, right? And now cur is equal to nil. So it's nil, and now we're going to do r.push stack.pop .val, which would give us the array here. I think this version would actually give us the correct answer, but only because our array is structured this way. I think for wait, TLE still? Wait, for this input array? Wait, how though? Okay, so the stack is equal to 1, 3, we're at nil, right? We do r.push stack.pop.val, which would put 3 in the array, okay? So now the cur is still equal to nil, and the stack isn't empty because 1 is in it. Well, cur is nil, so we're out here. Now cur equals stack sub -1. Ah, I see. So now we go back to 1, and then we do cur equals cur.right, which is indeed a problem. So we end up visiting this part over and over. Maybe I'm thinking maybe it's this double while loop structure that allows us to keep going left and then return to our position. Maybe we need to duplicate it to go right. And when you exit both of them, that's when you come out and you can do r.push. I think that's the problem we're running into. So what if we had a left stack and a right stack, or maybe should they be fused? Or maybe not maybe we can still use the same stack, but what we want is a value stack, because once we stop using, because we're using our stack to both keep our next order and our push order, and I think that might be a problem. So what if we had a value stack, and then once a node exits the left-hand side, right, once we do this thing right here, we do stacks of -1, we're actually going to want to do, I think, is stack dot pop cur equals stack dot pop. So we pull it off of the stack. Yeah, I think, and then we need this double while structure here. And I think I'll remove this one. Don't need this anymore. Move both of these. That way we could still work with cur, and then we'll have a right stack which is equal to an array. If we do cur equals stack dot pop, right? Now we'll have cur equals, you know, this value, cur does not equal no, or right stack, right, dot length is not empty. Right? And then in here we can say, okay, while cur does not equal nil, well, now we want to go right, and we'll do stack dot push, do right stack dot push. We actually want to do cur equals cur dot right here. And then here, right now I get it. And then here's where now, right now we can do, we can push cur onto, we can push value, we can push cur onto the value stack. So now we kind of let go of cur, and we can do cur equals cur dot right. Now we can go as far right as we want, right? Starting from this node, right stack dot push cur, and then cur equals cur dot right. And then once we come out, well, now we do so let's just follow this through with our current example. We have 1, right? 1 is equal to cur, right? Cur is not nil, but stack is empty. Cur does not equal nil because it's 1. So we're gonna push onto the stack 1, right? And then cur equals cur dot left, which is 2, right? And r is empty, and then we'll have rs with right stack, right? And then we'll also have the val as well, right? So now stack has 1 in it, but cur is equal to 2. Does cur equal nil? Nope. So now we're going to push 2 onto the stack. Right. then now cur equals cur.left. So now cur is equal to nil. Or we say cur equals stack.pop. So we take 2 off of the stack and we set it equal to cur. And we see value.push cur.val, which is 2. And then cur equals cur.right. Cur equals cur.right, which would be nil. Now, while cur does not equal nil, and right stack is also empty. So now we have a problem, right? Because now we want to use 2 as a starting point to go infinitely right. So our logic is incorrect right now. I think what we also want to do when we push value, we push cur.val into value, maybe we can do right stack dot push cur. So now rs has this 2 value, which it knows like, hey, I need to now go as far right as I can on 2. Right? And if we do that, then we'll say, okay, well, cur is nil, but right stack isn't empty. Right? So we'll say cur equals right stack dot pop. Right? So right stack will be empty, and cur will now be equal to 2. And we don't want to say right stack dot push cur, right? Because then we'd have a problem of us going in a loop. So we probably want to also say cur equals cur dot right, or we can just say cur right stack dot pop dot right. So now cur would actually be equal to nil, right? And it would be nil. And then in here, once we've gone as far right as we can, then we can do r.push value.pop. So then we'd have 2 in here, and value would be empty. But let's say 2 did have a child. What would we like to do next? I think what we'd like to do, right, is instead of doing right stack dot push, I think what we actually want to do is do stack dot push cur, right? Because if we did left, right, then we want to go as far left as we can. Then we want to go as far. If we can't go left, right, let's say we can go right. We want to go as far right as we can. If we find a node, that's the next node we want to go left on. This is a little convoluted, so we'll try it one more time with the input array. Or maybe we'll just try it with our regular array here. Right, so s is going to be equal to 0, r is going to be equal to nothing, cur is going to be equal to root to start, which is 1. Right, cur is not nil, so we're going to do stack dot push 1. Cur equals cur dot left, which is going to be 2, because of this, this is the tree up here we're using. Right, cur is still not equal to nil, so we're going to push on 2. Now cur is equal to nil because we're doing cur equals cur dot left, and there's no left child here. We're going to do cur equals stack dot pop, so now we equal to value dot push 2, right stack dot push 2, or we can just do it up here, right stack dot push 2, cur equals cur dot right, which is now 3. All right, so this is what we have. Now, cur is not nil, right? And right stack isn't empty. Wait, I'm getting wait, how could cur equal 3? That doesn't make any sense. We'd be at 2, right? And cur dot right would actually be nil. So both these are nil, we'd skip out and we'd do r dot push value dot pop. So we push 2 in here, value.pop. And right stack wasn't empty, so we do right stack.pop. And so we process 2. So let's try this. So we get 2, 1, 3. So I don't think this is working. I think we could get So I think maybe what we're going for, I think I think this order here, we want 2, 1, 3. We're actually getting 2, 3. We're actually getting 2, 1, 3. So I think what we actually want to do instead, if we skip this right stack part, because I think we're just duplicating work. And then we did cur equals stack.pop, which is what we're interested in. I don't even think we need to do this. We definitely want to do value.push cur.val. Then cur would equal cur.write. We don't have to do that because I think what we actually want to do is we're going to do right stack. Not cur dot. We want to push stack, or I guess we do stack sub last element in the stack, right? Dot val, and then we do right stack dot push stack dot pop. Now if we do that, we don't actually have to do cur does not equal nil, because we just want to do this if right stack dot length is not equal 0, and it doesn't. Because here we'd start at 1, right? Then we push, we'd go left, right? Oh no, I'm doing this the wrong.